Yep. Awesome. So, welcome to Python. If you are in this, so this should be 1051. I think I'm in the right place, right? 1051, everybody? Right? So you know that dream that you get sometimes where it's finals week and you suddenly remember there was a class you didn't go to all semester, and now you have to take ancient Egyptian algebra, which you haven't studied for because you didn't attend a single lecture, right? And then you wake up and it was all a dream and you feel much relieved. I have that dream too, only I forgot to teach a class. And it's the end of the semester and I'm supposed to give a final for the class and nobody's complained. So, you know, I find out where to go for classes the same way you do, which is that course website page or your scheduling page. For some reason, I'm supposed to put the time and place of the meeting in the syllabus, which didn't really make sense because nobody looks at the syllabus to find that out. Anyway, I am Professor Rosen. We will go ahead and get started. What I'm going to do today is I'm going to go over the syllabus, then I'm going to go and introduce you to our textbook as well as the basics of programming. This week in your lab, you will be installing Python on your laptop if you bring it, and you'll be learning basically the very basics of writing the very first Python program, which is Hello World, which simply makes your program print out Hello World. Then we're going to just build up a little from there using the techniques we learned. Okay. So two administrative notes are at the beginning of the syllabus. Notice that they're in giant font, right? The syllabus can be found on the Canvas webpage, which I'll show you in a bit. And I'm still updating it because I'm still tracking down all your TAs and ambushing them and asking them to please tell me what times their office hours are going to be. So first and foremost, uttering some variation of the phrase, "I did not know we needed to demo our assignments to receive credit," after the first exam will be grounds for an instant F in the course. Do not say this. Okay, what does demoing mean? We will get back to it, but the reason is because if you say this, then you didn't read the syllabus, and if you didn't read the syllabus, that means you're not going to read and you didn't bother reading this first page, which had giant letters in bold. Then you're not going to read directions. And if you're not going to read directions, you're going to kill people. Programming's serious business. But only if you don't read the directions. So the second thing is sign up for the textbook at runestone.academy. And this still has the old course name on it. I have it on the syllabus. I've got the let's see. I thought I updated it. Did I not update it? On this. So here on the web page, right on our course, you can find a copy of the syllabus under syllabus. Should be syllabus.pdf. And I should have updated this. Yeah. Sign up for, you'll want to sign up for the course Spring 2020 CIS 1051. Yes, it's a long string, but hey. That's the course for this. Your textbook is free because I wasn't a student that long ago and I hated paying for textbooks. In fact, I didn't pay for many of my textbooks because they're expensive and I'm poor. Or at least I was. So we are going to use this free open source textbook. It's very well designed. It's got runnable code segments. You can run a lot. If you don't have access to like your Python program, you can open up the textbook. So if you don't have access to your Python interpreter, you can open up the textbook and try coding in some of the windows it gives you in there. So it's actually a pretty good resource. All right, so course details. This is an introduction to programming if you are not a programmer or if you've programmed a bit. If you've programmed a lot, you should come and see me after the class. I know one person's already emailed me asking to test out, and I got to figure out how that's going to, if and how that's going to work. But the objective of the course is to give non-programmers enough programming experience that you can use programming techniques basically whatever you decide to do. I structured this course both as possibly the only programming course you take because you took this because you were interested, but you don't plan on getting a minor or going any further. as well, and you can use that wherever you decide to do, as well as the building blocks for the other classes, 1068, which is taught by Professor Fiore, and 2168, which is taught by me and a lot of other professors. How many, by the way, how many people? No, I tried to cancel the request. So, how many of y'all are not CIS students, not CS or IS&T? Right, the vast majority. Vast majority. And if you're in CIS, you're fine to be here. It's perfectly fine. You got to take 1051 or 1057. But there is, I'm catering to basically to most people who are either deciding to take this because it's interesting, programming is interesting, or because they're trying to get a minor or see if this programming is something they want to do. All right, time and place, see, have to put it in. You found it, congratulations. Skip this bit. It is a 4-hour course, which means that 8 to 12 hours a week is not it's not an unreasonable amount of work. The rule of thumb is like 3 hours out of class per credit hour. So 8 to 12 can be that, and most of that's just going to be like banging your head wondering what in the world you did, and then you realize, oh, it's because I didn't indent it properly. There's labs. You have to attend. It is assumed that they're required in the same way that your lecture is required. But I can't like tie you down or come in and abduct you from your house and bring you to lab if you don't go. So I mean, but you're expected to show up for those things. So we assume you've got a C in some mathematics skills. Just fine. Students are expected to know how to use a computer. E.g., you hopefully you know how to copy and paste stuff. Hopefully you know how to, if I tell you to look up something or open up something or go to a folder, you can. Now you might ask, if I asked you to go to your root folder or your home directory, you might ask, what's that? But once I explain it, hopefully you could go to there. So a laptop is strongly recommended, especially since we're using that online textbook. And if you cannot afford a laptop, come and speak to me, because you may be mistaken on that fact, right? A laptop, you can get a good laptop that will last you throughout most of your university, quite a decent chunk of the university life, for about $200 to $400. Is it going to be the greatest experience? No. Are you going to be gaming on it? Almost certainly not. But you can get stuff done with something that's fairly cheap. I made my way through grad school with a laptop that cost me $450. So there's a lot of resources for this textbook. Most of it can be found under page. A lot of stuff is under pages on Canvas. Specifically, the code I do in class, that's going to be there. Let's see, class information. Who made that page? Not sure. Some slides that some people did about labs, but as well as lectures. I record all my lectures. In fact, I'm recording this right now. Don't let that, it's not recording from there, it's recording from my laptop. I record almost everything on my laptop. And the reason I do this is because if you're sick, there's no reason to drag yourself to here to half pay attention and then collapse from dehydration halfway through the lecture. No need to come in and possibly infect other students, right? That's one thing. Another thing is that if you have trouble taking notes, want you to not stress out about it. Also, when you review, I want you to actually be able to review the content that you actually did. And, I'm sure you're wondering, wait a second, what was going on in this? My notes reference this, but I don't remember it, right? Well, you have this. I host it all on YouTube. Don't have any ads on my channel because I think it's kind of a bit wrong if I put in an ad every 2 minutes on a 50-minute lecture trying to and try to get money that way. That seems a bit weird. So there shouldn't be any ads on this. You should be blocking ads anyway. So, okay. So So that's one of the resources. The other resources are your textbook, which is at runestone.academy. Got to fix that link over there. There's also 2 other free textbooks I linked to one of which I will use possibly if we have time for something called regular expressions later in the semester. And another free textbook that I won't be referencing at all, but if you want another way to read something or another way for something to be explained, you can check out that textbook as well. Finally, Python does provide its own tutorial, so they have their own documentations. Some content, such as turtles, they won't be found in some of these textbooks. They'll be found in here, so just be aware of that. Office hours. I try to make my office hours fairly available. My office is in Cirque. It's room 349. My office hours are 3 to 4 on Mondays and 4 to 5 on Tuesdays. So in other words, after my lectures on Monday and after my lectures today. So that's when you can basically be assured to walk in, and I will and you'll have my full attention, right? Most Mondays and Tuesdays I'll be in as well. Just if you come and see me during those during non-office hour times, I might tell you I'm busy with something else. But Mondays and Tuesdays, that's good times to find me. I'll also be in for lectures, obviously, on Wednesdays and on Thursdays, but no guarantees that I'll be sticking around. If you can't meet with me during those times, send me an email, and I'll arrange a time to meet with you, Monday, Tuesday, Wednesday, Thursday, and if none of those days work, or you're a commuter and coming to school for a meeting doesn't really make sense, I can meet with you online, right? It's amazing what I can do with video chat. Advantage of having taught online classes is that I know how to make those work. Advantage of doing them when the people you're teaching is on other continents. I know how to make it really work. So we have 4 TAs for this course. Joanne is teaching 2 sections, but the TAs will also have office hours. Notice that I didn't list their sections. 1, because that's more work for me, and 2, because I don't want you to say, oh, if you're in section 1, you can only go to the section 1 TA. You can go to any of these TAs whose times work for you. And as you can see, there's still TBA because I'm still tracking them down and putting in their office hours. Also, free peer tutoring for all CIS classes is available in Cirque 358. That is the student lounge in the back of the 3rd floor of Cirque. So it's very, very close to my office. It's like right around the corner from my office. It is the room that has glass walls that you can look into it, and there's Macs all over on the sides of stuff, and there's 2 tables set up, one for TAs, one for tutors. Okay. There's some other executive summaries. You can read that yourself, but attendance, already went over illness. Don't copy stuff from the internet blindly, because especially if you're just starting out, I'll be asking you, what is this? Do you know what this does? And you'll be flummoxed and flailing around, and I'll tell you and that's not good. Now, I go into basically doing this. I go into a lot of detail, but essentially at the same time, I want you to work with other people, okay? So first off, a couple things. If you look up something on the internet and see, ooh, that's a fun way to do something, cite it. At that point, it's no longer plagiarism. If you cite it, it ain't plagiarism, just simply by definition of having cited it. Okay? Worst I can do at that point is ask you, do you understand it? And if you don't, I can tell you either do it in a way that you do understand, or to go back and redo it in a way that doesn't use that method. Right? That's the worst I can do at that point. But also, I want you to be able to collaborate with your friends. And if you do work with people, just put it in the comments that you work with this person and this person. Okay? That being said, you can't just simply copy wholesale from somebody else's work and expect to get through, because I'll be asking you to demo your work. More on that in a second. If you have disabilities or you need to contact me about disabilities, just send me an email. Or go through DRS, or send me an email. I will basically be waiting to the end of the week to go through all the notifications so that they can all trickle in, because people come in and out during the first week of classes. So just simply send me an email if you need to, or go through DRS. But if you find out something that isn't working midway through the semester or part of the way through the semester, just let me know. I do try to be as awesome as possible about this. So grades. Around a quarter of the class generally does not do very well, either gets a D, an F, or withdraws from this class, a quarter to a third. That being said, about a third of the class almost always gets A's in this class. And then almost everybody else who passes gets a B. There's very few C's in this class. You generally need above a 70 average to pass the class. So there are extra credits on assignments as well as on exams. So be sure to do those, especially earlier on in the semester when you've got time. And the exam breakdown and the assignment breakdown. So the breakdown on stuff is as follows: assignments 25% is 25% of the grade. Exercises about 5% of the grade, which are in other words textbook stuff on your textbook that I'll assign, which basically just meaning read your textbook and do the exercises in them. Most of that will be participation based, basically points for actually opening up your textbook and reading it and hitting the run button on examples. Quizzes will be done in class and they double as kind of an attendance grade. So you get free points for attending as well as points for actually doing the stuff correctly. Those also might be in-class exercises. Exam, 35%. We'll have at least 2 exams. Last semester I had only 2 exams, and I've been doing only 2 exams, but honestly, I feel like I need to do more exams, if for no other reason, because in a lower level class, I think more exams means each exam is worth less, which means that I can which means that each exam is slightly less stressful, as well as, you get earlier notifications about how you're doing. I will let you know at least a week in advance before an exam, and you will be getting a practice exam along with any exam. Exams are if not open note, then at least 1 page of notes, and I'll let you know about that. So, all right. So we'll be doing quizzes. Quizzes will be done on the phone or the computer, so just be aware of that. So I try to make it so that the quizzes can be done on the phone. If we do an in-class exercise and you don't have a laptop, I design the assumption for my in-class exercises is that you will be working with somebody, and there's at least twice as many so there's at least 1 laptop for every 2 people in a classroom, any classroom these days. Okay. So demoing. So turning in your assignments is a 2-part process. First part, submit to Canvas. That tells us when you submitted it, if it was late, and if so, how long it was. You get 5% off per day for anything for things that are late. That's pretty lenient. So that's part of that is I'm teaching a lot of freshmen, and some freshmen have this bad habit of deciding that World of Warcraft or the latest MMORPG is more fun than class, or possibly becoming very good friends with whoever's running the alcohol store. Freshmen are prone to making poor decisions in life, and this gives me a way to at least compensate for that. It's 5% off. And that's 5%, by the way, not 5 points. So first day is 95, second day is 90.25. So it's a cumulative decay according to that we'll be doing. Actually, oh no, I changed it to 5 points per day. But maximum penalty is 50 points. That means that basically anything can be turned in at any point for half credit. Okay? Second point is to demo it to your TA or me. Demoing basically means you show it to your TA or me, you explain pieces of your source code, you answer some questions from us. I might ask you to make a quick change to show that you understand it, or make a quick modification. Might look at your code and glance at it. This can be done after class, so like right after this class, although that's like the worst time to do it because everybody runs up. During my office hours, during any of the TA's office hours, but those are also not the times that generally you should do it. The easiest time to do it is during your lab, right? Which is the 2 hours during your schedule. So really that should be first, but also during our office hours is a good time to do it as well. And part of this is because I've got 150 students or something like that. Downloading 150 students' homework is always a pain, and then there's sometimes issues about you not including a file to get it to run, right? So, or maybe you even submit the wrong thing. No. Okay. Formal exams account for about half your grade. Don't miss your exam. Makeup exams are given by a case-by-case basis, but if you let me know that you're going to miss the exam before the exam is taken, generally I'll be able to make it up for you. Okay. And then final exam, find the final exam date here, which is this. I find out when the final exam is when the same way you find out where the final exam is. Okay. So, all right. I think that's enough formalities and stuff. Canvas, you'll find here the assignments we'll find over here. Pages, again. The lecture, click on the lectures tab. This has currently all the last semester's lectures, and that once I start uploading, this will have the lecture, this, I'll update that. And with that, let's go ahead and get started. So programming, or rather computer science, what the heck is it? Which is an excellent question, because if you ask like a million people, if you ask a bunch of computer scientists in general, you'll get a bunch of different answers about to what computer science is. But at the end of the day, computer science is what we call the study of algorithms. It's a science, the badly named degree, in my opinion, because you don't call astronomy telescope science, you don't call biology microscope science, but that's the equivalent of what we're talking about. Computer science is the study of algorithms. It's the study of problem solving. It's the ability, this is a class that actually maps well to a couple different things, like philosophy, right? Philosophy, they say it's all about thinking and critically thinking and building logic and stuff like that. Well, computer science is that too, just on a parallel track, right? Having to deal more with taking an actual, some problems and putting them out. And I'm not like downplaying philosophy. Philosophy is fun and all that, and they ask interesting questions about life. This asks interesting questions about problems. Computer science asks us, what can we automate? What does it mean to automate something? What is the difference? Can my computer really do any kind of problem? Are there problems that my computer can and can't do? There are stuff that computers can't do. Are our own minds limited? Do we face the same limitations that computers do? Right? So can we do things that computers can't do, or are we just really efficient computers? How efficient can things be automated? That's another question, and one that if you take math concepts of computing, or you decide to go up all the way to data structures, that's something where you'll start to learn about that. How efficient is it can things be automated? But computer science has a ton of applications. If you're in astronomy, astroinformatics is really big right now. Most supernovas are detected using basically algorithms these days. Let's see, if you're in biology, bioinformatics is probably something you've heard of, which is basically studying biology problems, processing biology problems using computer science techniques. Now, and if you're coming from like physics, astronomy, or one of the other hard sciences, or even something like psychology and sociology, which for some odd reason are not considered hard science, I don't know. I disagree with that. I think everything in science is a hard science. So it's easier to teach somebody in the sciences programming than it is to teach somebody who knows already a bit of programming, a bit of enough about biology to get get the domain expert work done. A little bit of programming makes you extremely competitive. So I've also spouted out this magic word a couple times, algorithm. So let me talk about what the heck an algorithm is. Right, so these are some useful notes that I've had. Hey, I said most of this stuff, right? So algorithms are, of course, if you want to make oodles of money, that you can do that with computer science too. High-speed algorithmic trading which is basically getting computers to trade stocks. Always big money, or currency, or whatever. If you're in psychology, there's an entire field called human-computer interaction, which is basically how do people use computers to do what they need. That's where I got my study in research done. I was like, if you're blind, how in the world do you use a computer? And that's where my undergraduate research was. Entire subfield of that dedicated to that. Basically doing auditory interfaces on the phone, haptic interfaces, which is touch-based. Also, education. How many of you played Oregon Trail, right? Learning games, education resources, educational games, that's an entire thing. So algorithm, the magic word I've been saying. The word algorithm comes from the Latinized name of Muhammad ibn Musa al-Khwarizmi. So they Latinized that to algorithmy. By the way, that might be on your first exam. So he wrote the textbook, The Concise Book of Calculation by Reduction, in the year 1820, and it is we get algebra from the title, which part of the title was algebaire. So you can blame him for algebra. He also wrote a book dealing with these newfangled, 10-digit numerals coming out of India. So he wrote about that and basically the base 10 system that we use today. That book was eventually translated to Latin, and then Latin basically means it got spread across Europe. So, this guy was he was a Persian mathematician. So that's where he's from. So algorithm. Now, there's this big formal definition for algorithm. You don't need to copy it down heavily. And again, remember, I am recording this lecture, so if you're trying to frantically record and keep up with me, don't panic. So the definition for algorithm is a set of well-ordered, unambiguous operations that yields some result in a finite amount of time. And I'm going to go through and digest that for you. Studying algorithms began in mathematics. Think about the mathematical algorithms for instance, let's see, adding stuff by hand, pain, such pain, okay, 476 plus 829, right? How do we add these numbers together, right? What is the process we can do that does this? It is well ordered. We know that the way to add numbers is to not start from here, but to start from the least significant digit, right? Unambiguous. You take two numbers, you add them together, you use the carry, and then you add the carries and the digits, and you keep going. It produces some result, right? We'll get a result. And the only reason it will be wrong is because we're human and we can make mistakes. And it will take a finite amount of time because the two inputs are finite, right? Even if they're really big numbers, like hundreds of digits long, we could work on it for a couple days and get it, right? So again, the algorithm is add the least significant digits. 6 plus 9 is equal to 15. So 5, carry the 1. 1, 2, 3, and 7, that becomes 10. So 0, carry the 1, 12, 13, and then carry the 1 over here. 0 plus 0 plus 1 is 1, right? So that should be 1305, probably. The higher you go in mathematics, the worse you get at the basic stuff. It's kind of actually hilarious to watch some professors struggle with that, including me. Right, so you've got basic algorithms like that. That's an algorithm. It's steps to follow. Personally, my favorite algorithm is the one that my wife followed last night to produce these for me, that I'm sharing with other professors, chocolate chip cookies. Recipes are, especially if you follow them exactly, are algorithms. And if they're well written, they are definitely algorithms because they tell you to do these unambiguous things in a certain order. It produces a result, cookies, and it takes a finite amount of time, right? So a program is a representation of an algorithm that we can read and that your computer can read. It's kind of a compromise. Your computer is kind of dumb. It's a rock we tricked into thinking. So it and basically all it understands is ones and zeros, which is small electricals, and really not even ones and zeros because it can't. It's a rock that we tricked into thinking again by shooting electricity at it. It doesn't understand ones and zeros. Ones and zeros, what are those? Numbers? I'm a rock. I can't count. Right? Instead, it is instead it understands high voltage, low voltage, which we just simply mathematically represent as ones and zeros or on and off. So to compromise, we use something called a programming language to talk to our computer and to give it instructions. A programming language is something that I can read, but also can be translated into those ones and zeros for the computer. Right? So programs are what we call software, where we've implemented some algorithm to do something, and the machinery that runs them are hardware. Soft because the software runs on this bit, and the hardware because this is hard. And we also have firmware for devices, and you think about it, soft, hard, firm, right? There's a reason we name it firmware, because it's between the software and the hardware. Okay? So, one of the big things over here is that a bunch of mathematicians basically kind of came up with really important insights in computer science. And you're not going to see this again until you hit, unless you decide to take theory of computation, like automata theory or something, right? It's funny. You'll see it here, but but the mathematics are kind of really deep. Bunch of people, Bacon, Leibniz, Boole, Turing, Shannon, Moore, they all basically came up with different things, saying that we can represent all of our information in zeros and ones. And you can represent zeros and ones basically using anything that's on, off, or high, low. Turing, Alan Turing of the British mathematician, you've probably heard of him at some point, and if you haven't, I'll go over him in a bit. He came up with basically this insight that you can produce algorithms using only 5 actions. Imagine you've got an extremely long piece of paper, infinitely long piece of paper, and you've got it divided in all these little squares. And all you need is this device that does 5 things. It can move left and right on those squares of paper. It can put a 0 down at the square. It can put a 1 on at the square. It can erase the square. Oh, and it can also read what's at that square. And it turns out that basically anything that's complicated and any complicated instructions you can just simply turn into these actions. Read squares or do one of these 5 things to modify the squares. That's crazy. And so the idea here is that, but the big thing to get out of here is that every single thing that we do on computers just gets translated to ones and zeros. And we can take anything and represent it using ones and zeros. Why don't we just program in ones and zeros? Because it's annoying and boring and hard. Literally, like part of one of the classes I took was, now that we've built like some hardware, let's go through them, and we've got ones and zeros and electrical signals. Let's go ahead and see what it's like to add 2 numbers. And we ran through adding 2 two-digit numbers for 20 minutes. And they're like, and so now we're going to try doing it in assembly and see why that's much better. The idea here is that all of our complicated, so the other thing we find out is that all of our complicated instructions can be written into 3 types of statements, and this is going to be the focus of the first few weeks. We can do 3 types of statements. Sequential statements, which are simple declarative statements. Do this, then do this, then do this, then do this, right? Preheat the oven at 325. Pour the butter, flour, into oil into the mixer. Right? Conditional operations or selection operations. If it's raining outside, grab the umbrella. go outside, right? These are basically conditionals. Say, we are going to check a condition, and we're going to make a choice based on that answer, right? If this is true, we're going to do this, or this, and we can stack these as far as we want. We can say, if it's this, do this. If it's this, do this. If it's this, do this. Or if it's this, do this. And if it's none of those things, do this instead, right? So basically, anytime we want to make a branching choice, that's a conditional statement. We call these a lot of times if statements. And finally, this thing that you're going to be struggling with for most of the next weeks, just simply because it requires thinking and holding a lot in your memory, but practice makes perfect on this one. Iterative operations, which is that we are going to repeat some task until a condition is met. We're going to do this until I count to 5. Or we're going to do this until I've done it 5 times. While this is true, do this, right? While the hole isn't filled, put dirt into the hole, right? For every item, for every page in the book, put a big check mark on it. So what we do is that basically we use, and pretty much any program can be written with these 3 kind of basic tools, which is statements, conditional statements, which are, or if statements, and loops, or iterative statements. We call them loops because that's one syllable, and that's easy to pronounce, and it's fun to say. So a very brief history before we start computing. Basically, the computers kind of had their beginnings with the abacus. That wasn't really that much of a computer, though. It was more, that's just a tool you could use as storage to extend the power of the mind because you needed to do stuff. It didn't really start until the 1600s, 1800s, until you had various scientists who had the idea of we can create these big gear-powered adding machines that we use gears, and we can use the position of gears to represent numbers, and then they can turn a certain number of times, and they automatically give you the answer. Pascal, Leibniz, Babbage, all different scientists, but Babbage was the big one we hear about because he wanted to create a beer-based machine. Rather than checking the gears and writing down their locations and translating that, he's like, well, wouldn't it be nice if we just took out that step and the thing just printed out to paper what it would be? So the first programmer was most likely Ada Lovelace, the daughter of, and she was the daughter of the English poet Lord Byron. So if you've taken English and studied Byron, this was her daughter. Now, her mother and her father got divorced pretty early on. And that was like the biggest thing. Imagine the 2 biggest, basically imagine, the biggest movie stars of the time getting divorced. That's how big it was. People were still sniping at each other about who was right and who was wrong after both parties were dead. Years after both parties were dead about that. Byron was a tumultuous person, impulsive, and basically, tempestuous is probably a good word for him. And so her mother, and so Ada's mother was we should, curb those passions and study something a bit more boring, like mathematics. And so Ada poured basically a lot into mathematics. So anyway, her analytical engine, so she worked with Babbage on his analytical engine, and it was designed but never produced. But, they had plans and stuff for it. And Ada, the idea here was that you could take, this analytical engine could take instructions from a paper card with holes punched in them. This is like something out of the 1940s here, or 1950s rather, and read these instructions from the paper card and then do the operations. Ada published a paper and had basically a small program on there, which is probably the first documented program we have, about how that analytical engine could be used to compute these things called Bernoulli numbers. And basically, so this was saying, if this machine is built, if we give it these instructions and hook up everything this way, then it will produce these things automatically for us. Also, she wrote about how the analytical engine could use to do work on things other than numbers by taking things like text and translating it into numbers. And that was about 100 years ahead of its time. Unfortunately, she died of cancer in like her 30s. And so it was just, that's just, and humanity as a whole lost. So the birth of modern cryptography started in World War II. And that was when basically, and you probably, if you've watched The Imitation Game, then you probably got a lot about the whole thing about at Bletchley Park about deciphering the Enigma machine. Alan Turing was one of many people on that team that worked on Ultra. So you had Ultra, so Ultra was basically the Allied effort to break the German ciphers. Magic was the effort to break Japanese ciphers. And if you had Ultra Magic clearance, then you were basically one of the most heavily monitored assets the United States had. It basically guaranteed you were never sent anywhere dangerous. But Alan Turing worked on the Ultra project to break the German Enigma machine. That's what he's pretty much famous for. But Eisenhower basically said that the Ultra project was decisive to an Allied victory. It lowered he estimated that basically it probably cut the year 2 years short, or the war 2 years short. Alan Turing, however, was persecuted because he was gay, and he was chemically castrated and committed suicide, I believe, in the 50s. So, also something, we seem to have a theme of computer scientists, at least prior to the 50s, losing out on a lot of geniuses. First computer, we don't really have any kind of any clear clear first for what the first computer is. An early so this is, by the way, Augusta Ada King, Countess of Lovelace. This is a picture of her. This is ENIAC, one of the first computers ever built. It is massive, and it doesn't do much because old computers really didn't do much. ENIAC stood for Electronic Numerical Integrator and Computer. Began in 1933, and it finished being built in 1946. It used vacuum tubes as the computer, and they would have to be replaced quite frequently. 1,800 square feet, so bigger than a lot of houses here we're talking about. And it was primarily used for artillery calculations. But things began to get smaller and smaller and smaller, and miniaturization has been the name of the game since then. To the point where basically all of us carry around a computer in our pockets. We don't think of our phones as computers, but they are. IBM introduces the first personal computer. In other words, computers that you personally could have as opposed to some big company paying for and having in 1981. So miniaturization and interconnectivity is the other big thing. The internet. Global system of networked computers. Basically, all computers talk to each other basically all the time now. Think about how much of your activity is spent in a web browser these days, right? I mean, like, I'd boot up a computer, play games on it, mess around on it, but I had no internet connection. And then that changed, and then you started to spend all your time just on one program, the web browser. Okay, so with that, we still have, I think, 35 minutes. So let's go ahead and get started with some programming now that we've got some of that out of the way. If you're going to take anything out of this, like what would I ask on an exam? So let's go ahead and talk about that for a second. Something I am prone to do is mentioning what will be on the exams up to and including the actual questions. Typically on the first exam, I ask you, what is computer science? And the not wrong answer is the study of algorithms. And generally, another thing is I generally ask you to know about some historical figure. I'm not going to ask you about it. I'm just going to ask you to tell me about a historical figure who knew about in computer science. That's actually your first assignment too, which is to look up a computer's famous figure in computer science. So now there's a lot of different programming languages out there, and all of them are terrible. There are only two types of programming languages according to Bjorn Strustrup, the creator of C++. Programming languages that everybody complains about and programming languages that nobody uses. So Python, however, is my favorite terrible language. I love Python. Love it more than Java. There's a lot of different options for programming. You've got popular languages that these days include Python, Java, C, C++, which have been around since C has been around forever, like since the 70s. Go is getting really popular. That's a programming language developed by Google. Ruby's very popular, I think, still. JavaScript, unfortunately, is still popular, which is the favorite language for everybody to hate on. But let's see, Rust is very exciting these days. There's a lot of different programming languages. But the thing is about programming languages, it's about learning it's not like learning English and then trying to learn Japanese, which are two very different languages with very different systems and very different grammatical structures. Learning one language is like if you try to learn, say, Spanish or French and then try to learn French. They feed off each other quite well. Or Latin and one of those languages that are based off of Latin. It's very easy. Or these languages are very closely related. And it's actually a bit easier. It's more, actually, I would say it's closer to learning two dialects of something. Because really you're just saying, how do I do things in one language versus another? Now, to get Python, you go to python.org, and you go to Downloads. And you can click on this. It will detect your operating system, and you can click this and install it. Installing this will also install a program called idle, which I'll get into a second. But why do I have to download a programming language? Well, what we're downloading is something called an interpreter. There's two types of ways languages translate things. The first way is compilation, which is it's a mess. Well, not too much of a mess, but let's go ahead and see. Do I have a program in C over here? No, I don't, and I have programmed in C forever, so I'm not going to do it because I'll make a mistake. But the idea here is that we program some language. I can show you in Java. Why not? Okay, Vim. Java. Oh, sorry, Vim hello.java. So this is a terrible way to program, which is in Vim. It's also an amazing way to program, but it's terrible for you because you're just starting out. So this is the way that a Java program looks. Public class hello. And now I gotta say the magic words: public static void main open parentheses string. Gotta remember the brackets there, otherwise it won't work. Magic brackets. Another curly brace. System.out.println hello, comma, world, semicolon, close braces, close other braces, escape, right quit. That's a program. And the way it works in Java is that I would compile it, which turns it into instructions that my computer can then understand. That's actually a bit of a lie. You'll learn more about that lie in Java. But for right now, it's a useful lie to say basically when I compile something, it turns it into it creates a new program that if I run it, my computer will understand the instructions. It translates it all at once. Here's that program that it compiled and translated to. C, almost completely unreadable. Oh, there's the hello Java. Oh, there's the hello world I asked it to print out. So you can recognize that, but most of this is just unreadable gobbledygook. Looks like, somebody just banged on a keyboard. But what it did is that it translated these instructions and turned them into instructions that the computer can understand. The advantage of doing it this way, compiling it, is basically that it's quicker to run that program because the instructions have been translated into the native language for the computer or something close to it. It's also been optimized, so there's a lot of common things that might be done to basically to translate some instructions you don't write that well into something more powerful. There's a lot of science behind it and engineering. Python doesn't work like that, though. It wants to be easy to program in, so instead it's an interpreted language, which are a bit more freeform and loose with the rules of grammar. A bit more concise is the big thing, right? You saw all those things that I had to do in order to write a program that does this. Prints out hello world. To do the equivalent in Python, I have to jump through a lot of hoops. Hello.py. Print hello, comma, world. Python 3 hello.py. Okay, that's it. That's all I have to do in Python to get it to print it out. Now, most of the time, you aren't going to be actually working in the command line. It's a terrible idea to do this because, well, actually, it's not a terrible idea. And it kind of raises your geek cred a bit. But, I just did that because I had this available. Once you download this and install the Python interpreter, which will allow you to translate those lines into computer instructions, and big thing about interpreters is that's a program that's already been written. So you need to download one that's specific for your operating system and your computer. So for instance, if you're running Windows, you'll have to download one link. If you're running a Mac, you'll be directed to another one. I'm running Linux, which is a completely different operating system than both of those. Doesn't matter what operating system you use to program it. So it doesn't matter if you don't need a Mac to program, you don't need a Windows PC to program. You can program in pretty much anything you want. But you download this program made for your computer, and then you will get something called you'll be able to run Python programs. Now, the most common way the way I suggest doing that is to use a program that comes with that download called idle. Now, if you're a fan of Monty Python, you'll be happy to know that so was the maker of Python. In fact, Python's named after Monty Python. And a lot of things are named after various skits of Monty Python skits. Idle is named after Eric Idle, one of the writers of Monty Python. I think he was one of the writers. He was some way related to the Monty Python thing. But it is what we call an integrated development environment, it's a very basic one of those. Basically, it is a small window in which we are able to do programs. And I'm going to go ahead and increase the font size, and I'm going to do this right now because I want to show you how that works. So, because I don't believe in using itty-bitty-bitty tiny fonts. I don't like that. Strains your eyes too much. No reason to do that. Options, configure idle. First thing you'll want to do is make sure you're using something called a monospaced font. A monospaced font is a font like Courier New or Consolis or Droid Mono. And what those are fonts that basically that every single character takes up the same amount of space, the same amount of width. And that's because it makes it easier to line up. I use something called Fira Code. And over here I'm going to adjust the size to, let's see, how does that look? I'm going to probably adjust it to something much easier for you guys all to see. Yeah, 29 is a bit much. 25. Yeah, it should be perfectly fine. Apply. Right? Mainly, again, the reason that I need to do this is so that you can see what's going on. Now, most of the time, you aren't going to be programming in this window over here. This is what we call, when you run idle, it will pop up with a Python shell, or what we call a REPL, which stands for read, evaluate, print, loop. In other words, what it does is that it's going to read an instruction, evaluate it, print out the result, and then loop. It's a great way to do some quick and dirty tests. Like, for instance, I can test out doing mathematical expressions. 4 plus 5 plus 6, whoops, is equal to 15. Accidentally hit the slash there, and it didn't do anything, so bad example there. Or how about 30 times 25? 750, right? So you can basically start using it immediately as a really nice and advanced calculator. But most of the time we aren't programming in here. We will be programming instead in an editor. So what we want to do, you don't want to write a program like this and say, okay, we're going to write a for loop here, because if you make a mistake, you have to back up and retype everything. You're literally feeding it one line at a time. Instead, what we're going to do is create a script, like for an actor, but for your computer. It's a script for your things to follow. It's a program, an algorithm, a series of well-ordered, meaning they have a certain order, unambiguous. So if they're not commands that Python doesn't recognize, it will yell at you. Well-ordered events that it's a program that will end, and it'll produce some result. So let's go ahead and try writing hello.py again. Yes, I'm going to overwrite it. So here, what I'm going to do is I'm going to type our first Python command that we learned, which is the print command. The print command takes in what we call a string, which is a bunch of text between quotation marks. Single quote or double quote, it doesn't really matter in Python. So print hello world will when we run this script, it will print out hello world. Notice that I've got two double quotation mark here. Okay. And then to run the script, you just hit F5 or hit the run button over here, run module. And your output comes up in this shell. It says restart, and then it says this is the program I'm running, hello world. If I were to change this program, turn it into all caps to make it seem like I'm shouting at you, hello world, and I run it. There I just hit F5 to run it. It goes, hello world. It responds to the changes I make. Print, how are you? Question mark. Notice over here I used single quotes. Doesn't matter whether you use single quotes or double quotes, so long as you open it and close it with the same quotation mark. Hello world, how are you? Right? So instruction 1, print hello world. Instruction 2, print how are you? So follow those instructions. Not too exciting there. Okay. Print. So we can print out strings. We can print out mathematical expressions, 4 plus 4 as well. 8. Well, and notice that we didn't print out the line 4 plus 4. Notice that this isn't in quotation marks. Quotation mark is text that we literally want to print out. If it's not in quotation marks, it's an expression. More on that later. This week, basically, your assignment is 2 things. The first is to do this very basically. And all you need to know is the print command and strings. The first thing is printing out a 3-sentence biography of a famous computer scientist who's not Alan Turing, who's not Steve Jobs, and not Bill Gates. Not because I don't like any of those people. I think they're all awesome in some various ways. I just would get half the class writing about one of those 3 people otherwise. So, a bit of variety. If you want my opinion, you should write about Grace Hopper. And then the other part of your assignment this week is to create some ASCII art, which I have some examples of in the PDF. Nothing too advanced. The entire idea is basically getting Python installed on your system and making sure you can run it. Now, text, and again, text is pretty awesome here. Let's see. Now, Python is, now there's two versions of Python. One that you're going to be using by default is Python 3, which is a modern programming language, which means that it assumes that there's other languages besides English. So give me 1 second to see what I can do over here. Keyboard shortcuts, no. Region and languages, add a language. Okay, let's see, do I have Japanese? Add Japanese. Does that work? And swap, or do I have to do the other one? Yep, need to do the other one. Trash that. And Japanese. Add sentence. Okay, and Japanese input mode, hiragana. How do I switch between languages? There we go. That's how I switch between languages. Awesome. So for instance, if you wanted to type in Japanese, you could go print. Let's see. Konnichiwa. And then switch back. And then it prints out text just fine from another language. And believe it or not, that's phenomenal because other programming languages have issues with this. In fact, because well, let's just say that that originally programming was very Anglo-centric, right? You had 8 bytes for characters, which we'll learn why that is later, means 128 characters that are dedicated, and then you could have another 128 characters for whatever your particular language required, which was great for maybe French and Spanish. Really fell apart with Chinese or Japanese, which have way more than that. Way more characters. So Python is capable of dealing with that stuff. So let's go ahead and keep going with this. So how are you? Print. Now, because we use if you're thinking a bit, you might be thinking, well, wait a second. If we're using quotation marks like this, okay, what if I get into this issue where basically where I wanted to quote something? Your professor says, whoops, that was me just hitting something. Do your homework. Right? Notice that basically that is not looking so hot, right? A lot of programming languages and editors use this feature of coloring called syntax highlighting. That's what's going on, why the print is purple and this text is green, so you can see what's going on and kind of quickly identify those kinds of things. It's of questionable help. It's better than not having it, but the question is, like, should we possibly but you don't color your verbs one thing and color your nouns another thing, which is essentially what this is doing. Should we possibly make variables different colors or something like that? That's actually a very interesting research question. Anyway, your professor says, do your homework. Notice that basically that it looks like Python doesn't like this, and if I try to run it, it says invalid syntax, right? And that's because what's going on here? It saying print, your professor says, and then I end the quotation mark. Because a quotation mark means the end of a string, right? Do your homework. Quotation mark, end of that quote, right? So we're in the middle of an issue. So let's see. 1 second. So how do I get around that? Now, in Python and other programming languages, we use something called escape sequences, which means we create special combinations of characters to basically say, actually what I want to do is print out this. So if I do slash quotation mark and slash quotation mark over here, what I've done is created what's called an escape sequence. And this says, basically, so Python knows if it sees a backslash, it doesn't want to actually print out an actual backslash. What it wants is to print out a quotation, is basically see what the next character after that is, and then do something special. So slash quote means, oh, don't end the string. We want to print out an actual quotation mark. So if we run this, your professor says, do your homework. Make sense? The idea here is that I can't use this just normally. So instead, I use what's called an escape sequence. Escape sequences are also useful for other kinds of things, like print, here are numbers on separate lines. 1, 2, 3, 4, 5. Right? Notice that these guys aren't green. Oh, end of string while scanning for. It says, hey, you ended the line without closing something. Python really likes your commands to be on one line. Other programming languages don't care. In fact, you can cramp everything into one line on other programming languages. Python likes one instruction, one line. Thank you very much. It can be a very complicated instruction, but one instruction per line, please. So we can use escape sequences like this. /n, 1. /n, 2. /n, 3. /n, 4. /n, 5. And what does this do? /n is another escape sequence. /n is another escape sequence. It simply says, if you see a /n, I don't want you to actually literally print out /n. I want you to print out, a new line. Another useful thing is when you're trying to line up things. Print here are the populations of some cities. Print 1,000, print 12. Notice I'm just I'm printing literal numbers here, or numbers and strings rather. 16, print 50, 500, and 500. And right now, the text, if I print it out, it's left justified, right? Meaning that all the text is lined up on the left. So say you want to add up these numbers. It's a bit tricky because, well, these aren't all thousands place. These are one places. These are ones places, right? Or sorry, these are 1,000 place. Here's the tens place, hundreds place. They're not all lined up. So instead, when we deal with numbers, we like them right justified, which means we'd like them all to be indented over the same way. So here's another. Here's the other common escape sequence, /t. Any guesses to what that's for? Tab. /t gives you a tab. which did not line it up at all the way I wanted, but hey, at least it's all indented the same way. And this is where basically having a monospace font, by the way, comes in handy. Notice that it's like, oh, I could just simply do this. And now it's all lined up. Monospace fonts are great for this kind of lining up with, to make stuff line up like that. If we weren't using a monospace font, so for instance, we were using, say, Arial. Do I have Arial on this? It's fine if I don't. Let's go ahead and just grab, I'll just use Fira Sans, a non-monospace font. Apply. Notice that it's not that basically that these things don't line up anymore. Right? Notice that the one is a different width than other things. It's very hard to line things up, and you really need things to be lined up in Python. So it's very important that you use a monospace font. And it will use, and when you boot it up, it will set you to use a monospace font by default. So it's not something you have to really change. But if you decide to change the font, make sure it's monospace font. Okay. So let's see, what else can I do in the 10 minutes we have remaining? I can give you a brief introduction of the things we're going to be doing in this class. So the textbook can be found on Runestone Academy. You go here, you can go here, you create an account. I very much would appreciate if you use your real name to sign up, right? Just simply because that will make it easier for me to figure out who is who when it comes time to put in grades. You'll enroll in a course. Use the code Spring 2020 CIS 1051, and it has all these things. It's got a bunch of projects there. I'll start assigning stuff at the end of the week. It will give you a due date of when to read these things. And it talks about all sorts of things. It gives you check marks to see what you've done. Go over here. And what's really cool is this over here, right? Here's a text box. Let me increase the size significantly here so that you guys can see it. You hit save and run, and your output appears below. So even if you don't have Python installed, or you're using a Chromebook or something, you can still program using this. Has multiple choice questions. Check me, that's wrong, right? But the print function displays value onto the screen, right? You can check me and then hit the completed button. And then you can, but basically it's a very nice textbook for that, for this kind of things. See, what I want is preview things to come. Yeah, preview of the end goal. Let's see. So some things that we might get into the class. There's some image processing stuff we can learn about in this class, like for instance taking this picture, turning it into a grayscale picture. Right there it is, working on it. So this is the kind of things that you can learn fairly easily how to do. We can, but one of our things we'll do very early on is start by using a very basic graphic systems developed in the 60s called Turtles. And we'll spend a lot of the first couple weeks working with Turtles, which are basically very basic graphics. Essentially, given these instructions, which is saying set the color, the turtle to green, forward, up, and we can basically make some very basic kinds of drawings using Turtles. Very easy graphics, very easy way to learn about doing various things. So let me just show you an example. Python turtle documentation, because it has a very good program in there. I know. Grab this, boom, 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 boom. So, for instance, type error A is undefined in line 7. A is undefined in line 7? What A? That's the issue, and I try to grab that code. Whatever. Start and run. Here we go. So you can get things that just go like this. You know, you can give the, basically very basic directions on how to draw stuff. Very simple, repetitive directions on drawing things. And it will draw things, which is pretty cool. So you can do a whole lot with programming. Error because there's a time limit for how long these programs can run. But your textbook is very good. One of the things it was designed for is actually for something called a flipped classroom, which is basically where you would be told to read the textbook before coming to class, and then we would do exercises in class. We might experiment with that, and I'll let you know when we would experiment with that. So anyway, that is it, I think, for today. I think this is off to a good start for this. I didn't want to hit you too much on the first day. So tomorrow we'll start Thursday we'll start really getting into programming. If you want to speak to me, come up over here or meet me at my office at 4 o'clock. 1 second.